Assalamualaikum warahmatullahi wabarakatuh. Saya mau Farid dan kawan-kawan Swenagi 2020-670-778 here with our group to present for algorithm analysis the greedy algorithms for the coin change problem.
Okay, this is our content. We have introduction, roles and duties, problem statement, solution pseudocode, and conclusion.
Introduction. Algorithm design techniques play a crucial role in solving optimization problems efficiently, particularly when problems involve minimizing costs, time, or resource usage. An inefficient algorithm may lead to excessive computation, increased response time, and poor system performance, especially in real-time applications. Therefore, an appropriate algorithmic paradigm is essential to ensure both correctness and efficiency. One commonly used algorithm is the greedy approach. Greedy algorithms construct a solution incrementally by making a locally optimal decision at each step, with the hope that these local decisions will lead to a globally optimal solution. In this project, the greedy algorithm technique is utilized in the coin change problem with the assumption that the coin system is canonical. To further elaborate on the coin change problem, it is a classic problem that demonstrates the effectiveness of the greedy technique, particularly when dealing with canonical denominations. In many real-life systems, such as vending machines, parking meters, automated toll systems, and ATM machines, the objective is to return change using the minimum number of coins possible. The coin change problem provides a practical and intuitive example of how greedy algorithms can be applied to a real-world financial system. This project focuses on solving the coin change problem using the greedy algorithm under the assumption that the coin system is canonical. In canonical coin systems, the greedy approach is guaranteed to produce an optimal solution, making it an ideal case for demonstrating the efficiency and practicality of greedy algorithms. I will pass this on to my groupmate.
Our group divided tasks based on individual strength. First one is Ani Irfan designed the greedy algorithm solution and prepared the pseudocode. The next one is Adam Ahmed analyzed the coin change problem and its real-life application. Next is Muhammad Iskandar, which is me, implemented and tested the algorithm. And the last one is Muhammad Amar, handled documentation and presentation. Move to problem statement. In real life, payment systems such as vending machine and ATMs, machine needs to return change quickly. Look example. Given a fixed set of coin denomination and a target amount, the system must return change using the minimum number of coins. Checking all possible coin combinations is inefficient and slow. Therefore, this project used the greedy algorithm to find the optimal solution efficiently for canonical coin system.
So for this problem, we use the greedy coin change algorithm. The idea of greedy is to always choose the largest coin denomination that does not exceed the remaining amount. This approach works optimally because the coin system used is a canonical coin system, where greedy guarantees the minimum number of coins. For example, using Malaysian coin denominations such as 1 ringgit, 5 ringgit, 10 ringgit, and 15 ringgit, the algorithm starts with the largest value. If the remaining amount is greater than or equal to 50 ringgit, the coin is selected and subtracted. This process is repeated using the next largest denomination until the remaining amount becomes zero. In terms of performance, the time complexity is O. In N, since each denomination is checked once and space complexity is 0 is O, 1, because only a few variables are used. And this is our pseudocode. This pseudocode shows the step-by-step process of greedy approach. First, coin denomination and target amount are taken as input and sorted in descending order. The algorithm then repeatedly selects the largest possible coin, subtract its value from the remaining amount, and increment the coin count. This continues until the remaining amount becomes zero, producing the minimum number of coins.
Okay, Assalamualaikum. My name is Adam. I'm going to present about the code. We have two parts. The first is the greedy coin change and the main function. Okay. Mm, when we talk about the greedy coin change, it will receive the argument of array of nodes and the amount. Okay, and it will create a map it create a map variable, and the amount will be assigned to another variable. Okay, the for loop is actually for the array and the amount to be compared. Okay, the first step is um, the array will be look in one by one, and then it will be compared with the remaining amount in the code. Okay, and it will return the result, and the remaining amount at the end should be zero lah. For the second part is actually about the calling of the greedy coin change function. Okay, when we call the function, is actually going to receive the value in map. That's why we create a map object in the main function. Okay, and the result will show us that the number of nodes used for the amount that the user put in, and the number of nodes used. For example, we can see 50 times 2. It means that it will use 2 nodes of 50 ringgit, and the total nodes is 2. Okay. Okay, usually the use of greedy is at the automatic teller machine, as we all know as ATM, but it's not enough. During For the ATM system, they will use some constraint to control the greedy algorithm. Okay, that's all for me. Thank you. Okay, Assalamualaikum. My name is Adam. I'm going to present about the code. We have two parts. The first is the greedy coin change and the main function. Okay. When we talk about the greedy coin change, it will receive the argument of array of nodes and the amount. Okay, and it will create a map variable. And
Conclusion. This project was able to solve the coin change problem by the greedy algorithm based on the premise of the canonical coin denominations. The algorithm works well to reduce the number of coins in total needed to make a particular amount of money by always choosing the largest possible coin value in each step. Greedy choice properties and optimal substructure allow the algorithm to generate an optimum solution without searching through all combinations of coins, thus making it less computationally expensive than exhaustive methods, making it very practical in the implementation in real life, as in vending machines and ATMs. The linear time and constant space consumption guarantees rapid execution and minimal resource consumption, which is required in real-time financial systems. In summary, this project highlights the need to choose a proper approach to algorithm design depending on the characteristics of the problem, and it proves the effectiveness, simplicity, and practicality of the greedy algorithm in the canonical coin system because of its success in its implementation. That is all. Thank you.